Before we can talk about the multiplication rule, we first have to cover some concepts. And we will do this by looking at an example. Let's suppose that we have a bag. And in this bag, we have 8 blue blocks. And we have 4 red blocks. And the experiment is going to be to draw 2. And we're going to specify that these will be drawn without replacement. And essentially what that means is that we're going to pull one out randomly without having any knowledge of what it is, put it back, and then do that again. And a good way to describe this particular experiment is with what is called a probability tree. We'll start with our first draw. This first draw could result in a blue block or a red block being taken out of the bag. Now, the probability that I would draw a blue block would be 8 out of 12. There are 8 blue blocks in the bag and a total of 12. The probability that I would draw a red block would be 4 out of 12. Now I'm going to move to my second draw. Now on my second draw, I could either draw a blue block or a red block. And this second draw could result from drawing a blue block on the first draw or drawing a red block on the first draw. Now, if I draw a blue block on the first draw and don't put it back, then the probability that I would draw a blue block on the second draw would be 7 out of 11. Because if I've drawn a blue block, there are only 7 left, and there is 1 fewer block in the bag. If I draw a blue block and then a red block, the probability that I would draw that red block would be 4 out of 11. The probability that I would draw a blue block if I have already drawn a red block would be 8 out of 11. And the probability that I would draw a red block, given I drew a red block on the first draw, would be 3 out of 11. And it's that term given that we are going to concentrate on right now, given. This particular draw here, the blue block, given I've drawn a blue block on the first draw, its probability notation would look like this. The probability that I would draw a blue block given, and this horizontal or this vertical line means given that I have drawn a blue block on the first try. So we interpret the vertical line with the word given, and this particular form is called a conditional probability. So this notation means I have a conditional probability, and this particular conditional probability, the probability that I would draw a blue block, given I drew a blue block on the first draw, is 7 out of 11. We can read it right off the tree there. The probability that I would draw a red block, given I drew a blue block on the first draw, is this 4 out of 11 probability. The probability that I would draw a blue block, given I drew a red block on the first draw, is this 8 out of 11. And the probability that I would draw a red block, given I drew a red block on the first draw is 3 out of 11. Now, all of this brings us to the multiplication rule. In order to get from the beginning of a tree to the end, we multiply the branches. And really what's happening here is we're drawing a blue block and a blue block, or a blue block and a red block, or a red block and a blue block, or a red block and a red block. And this term "and," which also is signified with this symbol intersection, this term means to multiply. And the formula looks like this. The probability that event A and B would occur is equal to the probability that event A would occur times the probability that event B would occur given A has already occurred. So in each one of these cases then, in order to get to the ends of these branches, we would multiply. We'd have 56 out of 132 from the first branch. We would have 32 out of 132 for the second branch. For this third branch, we'd have another 32 out of 132. And by the way, it is not a coincidence that those two probabilities are the same. They both result in the same situation at the end of that branch, a blue and a red and a blue. Either way, I'm holding the same arrangement of blocks in my hand, either a blue one and then a red one, or a red one and then a blue one, but it still gives me a blue one and a red one in my hand. And then this last branch would be 12 out of 132. Something else that is interesting to note and not a coincidence and has to happen is that the sum of all of those probabilities has to be 1, which this is. 32 and 32 is 64, and 56 is 120, plus 12 is 132. So we have 132 out of 132, or 1. So this always has to sum to 1, because it represents every possible thing that could happen if we conduct this experiment.